I'm going to show you a few of these problems, or more or less discuss them to whatever extent I can, being as I'm losing my voice. Okay? At least offer you some suggestions. No need that I necessarily have to look at these in order. Okay? These problems, of course, we addressed in previous videos. Alright? So they shouldn't be any problems just using the inverse trig function. Same with tangent. Explore that a little bit though for yourself. Tangent and inverse tangent on Desmos. You might be interested in that. Well, these problems down here, okay, look like much the same kind of problems as we had before. Well, they're quadratics in trigonometry. So factor it, find the answers, find out when the sign is equal to whatever values. In all likelihood, they're not going to be the familiar values. They're going to be something more like these. Okay? So then you'll know what to do with them. Have fun. So you have a couple of those. Same thing. Same thing. Okay? Use the identities you have available. You know, cosine, double angle cosine. Okay? Double angle cosine. Okay? Redefine that. Again, if you're not getting, you know, values like root 3 over 2, root 2 over 2, or anything like that, but you're getting values like, you know, 2/3, 1/4 or something, then you know you have to use the inverse trig in order to evaluate them. So just proceed with them. Okay? Alright, now, probably some of the more interesting problems are going to be here. Okay? Now, these couple are going to refer to right triangulation, whereas basically the answer to an inverse trig question is an angle. So if I'm saying, what is the inverse tan of 24/7, that I'm talking about in some right triangle, there's an angle such that the ratio of, okay, the tangent ratio, opposite over adjacent, is 24/7. Looks a little off here, so as not to be so far gone. Let's just set that up differently. Okay. So here's my 7, here's my 24, and here's my angle alpha. Okay, so the opposite over the adjacent is 24/7. I trust you recognize that as a triplet of 25, which you could ask the cosine, the sine, or any of the other trig functions. Likewise approach to these. Okay. Likewise the same approach. This is a similar approach, but more algebraically speaking. So all expressions will be in terms of x. These are values, and you know the inverse sine of 2 over 2 is pi over 4, remember, because the inverse trig functions are 1-to-1. We're only going to get, okay, a single solution out of each one of these. Again, this is another familiar value, pi over 4. So that's going to give us pi over 2, which actually is going to be one of our own defining inverse trig inequalities. Alright? The tangent inverse of 4/3, that's reminiscent of what we did down with the right triangle. And subsequently find a cosecant. Okay? So let's go up to these first couple, which maybe I should have put lastly, but it makes a difference. Okay. Um, surely. Okay. This is one that you shouldn't have any problems with. Okay. The cosine is root. The cosine inverse, that is a pi over 4 reference. Of course, we gotta recall what the graph of the inverse cosine is looking like. So here's my graph of the inverse cosine. So I'm taking the negative pi over, the negative 2 over 2 over here. I'm picking off the pi over 4, which is actually the 3 pi over 4 value. Okay. Then I'm asked to find, so what is the tangent of 3 pi over 4? Okay. F of 1 half. Okay. Put that in. The inverse cosine of a half. Okay. I'm sure recognize that as a familiar angle to you, and then subsequently, so you can see these are compositions. Okay. And if you take them on that front, it shouldn't be too bad. Just remember the graphs. That because of the shape of your inverse sines and cosine graphs, okay, your one-to-one, have a hard time drawing that. Those are the shapes of your inverse trig graphs, one-to-one, which is to say, you pick up a single solution. Okay, so just looking for the sine, didn't have it. We did the cosine here. Okay. So here's the inverse sine. The inverse sine of a half, of course, is with the half value, positive half, and pick up that, which is the pi over 6 value. And then you evaluate the secant of pi over 6. Okay? So that's your exercises. I trust you'll be